We introduce ARFlow Plus, a high-performance framework for multi-device AR experimentation. AR research is evolving fast, but evaluating multi-device AR setups in real-world environments is still painfully difficult. Synchronization is unreliable, and existing tools weren't designed for collaborative experiments. AirFlow Plus solves this with a redesigned architecture. Clients stream sensor data using gRPC, synchronized via network time protocol, and spatially aligned using ARFlow markers. Everything is logged and visualized live with rerun. We start at the command line. AirFlow Plus Python package comes with a command line interface that allows you to launch an AirFlow server in either the view mode or the save mode. For this demo, we opt for the view mode to see what gets streamed to the server in real time. But before we start the server, we query for the server's IP address, which will be used later by the clients to connect to it. Once we have the server's IP address, we can start the server in view mode. Once the server is up and running, you will see the rerun viewer pops up in a separate window. This is where the streaming data to the server is displayed. Next, let's head over to the client. Here we have an installation of the ARFlow client mobile app on two devices side by side. When it first starts, it asks for an IP address that hosts an ARFlow server to connect to. We enter the server's IP address that we obtained earlier, leave the default port 8500 as is, and tick the checkbox asking if the NTP server host is the same as the ARFlow server host. You can read more about the NTP option in our contributing guide linked at the end of this demo. Once we have connected, we need to create a new session to store the data from these two clients. We can do this by clicking on the Create New button and fill in the info. This creates a new session on the server and allows us to start streaming data to it. On the other client, we refresh the list of sessions with the Refresh button, select the newly created session, and join it with the Join Selected button. Once both clients have joined the session, we can align the origin by clicking into the Align Origin and then Scan for Marker buttons. Next, we point both cameras at the same arrow marker until the Finish button turns green. Once the marker is scanned, we click the Finish button to finish the alignment process. This ensures that both clients are aligned to the same origin. Next, let's choose some types of data that we want to send. Let's choose all the available data modalities on both clients. Hit Start to begin streaming data to the server. You can see the data being streamed to the server in real time. During streaming, you can turn on and off any of the data modalities at any time. You can also switch between different resolution and frame rates for the camera color modalities. These changes are reflected on the server in real time. Once you are done streaming, you can hit pause and view the collected data in the rerun viewer. Here, you can play back the data and view the data in 3D. You can click on interactive elements within each modality to view the specific statistic belonging to them. Looking at the streams pane at the bottom, You can see how the data streams are organized. Two client devices are in the same session, each with their own streams of data modalities. Lastly, you can export this recording session data to a rerun data file, which can be shared or opened in any rerun viewer instance for later viewing or analysis. Now that we have seen ARFlow Plus in action, let's take a look at our experiment results to see how it has improved over its predecessor. With a single error code scan, devices sync their coordinate systems. This reduces rotational offset to just 4 degrees, ensuring every device sees the same space. ARFlow Plus uses Network Time Protocol or NTP to synchronize clocks across devices, cutting timestamp drift from 700 milliseconds down to just 70 milliseconds. Accurate timing means reliable, aligned sensor data across all devices. Our batching design enables high-frequency streaming, up to 30 frames per second, color data from 5 devices simultaneously with minimal latency. ARFlow Plus supports both real-time and offline workflows. Whether you are debugging spatial issues or running long-term studies, it scales with your needs. With precise synchronization, efficient streaming, and intuitive visualization, we hope that ARFlow Plus will empower the next generation of AR research.